is Oleg. I'm very happy to be here with you. This is my first time in Chicago. Well, yesterday was first time in Chicago, but now it's still the same trip. And today we're going to talk about Testcontainers, which is a collection of libraries that simplify integration testing, and it's all around great. So we're going to talk about integration tests, and we're going to see how Testcontainers can help you with creating ephemeral setups for your integration tests, and look at maybe some best practices and some core concepts. So after this session, you'll be ready to go and enhance your tests and make them like higher level functional integration tests, and not suffer from hating your life after that. Which is, there are different conditions for everyone, but like, you're not gonna hate the integration test here, right? So I work for a company called Atomic Jar, which is a little startup that is created by the maintainers of Testcontainers Java library, which is the Java version of the Testcontainers implementation. I work in the developer relations team, which is why I can come to various cool places and talk to excellent people like you here. And if you have any questions that you don't get to ask today, well, you can very easily find me online. I love chatting with people online. You can ask me about test containers or integration tests or like life advice in general. I'm old and wise, so I feel like I have expertise on all matters. Right, and I'd love to chat. So before we start, I just want to give you a little bit of a background why I feel integration tests are very important and why, in general, tests are important. In software development, testing and good tests are the universal answer to almost anything. Like all the questions. Can I merge a PR into the repository, right? Do you have tests? Do the tests pass? If yes, you can merge them, right? Are you making progress towards like delivering the feature that you were working on? Well, have you written tests for that? And like, are the tests passing more than they were before? If yes, you're making progress. If no, you're not making progress. So test is the answer. Are you breaking somebody else's code when you were working on something? Well, you need to run tests. Can you run their tests? Are they passing? If yes, then you're good, right? If not, you will have conversation and stern looks when you merge the things that you're working on, because you'll break someone else's work. What's the secret to having like a healthy and luxurious hair? Genetics and personal hygiene, but if you thought tests, I like your mindset. Right, so tests are important. We know that tests are important. It doesn't have to be like test-driven development. Like it doesn't matter that much when you write your tests, right? To me, I think my personal opinion, if the tests are in the same PR without a reviewer asking you where are the tests, then you're doing test-driven development enough for me, right? If the tests are in a consequent PRs, then you might maybe look at your like process, how to maybe make it more convenient. But tests are great. And when we talk about tests, most developers usually have something like this, a picture like this in mind. So how to organize tests? There are different types of tests. There are unit tests that everyone loves, everyone knows how to write. They're small, they verify the behavior of individual component in isolation. They're easy to write, you can run them from your IDE. And they normally, in the projects, they try to be like the base of the test suite. And then on top of them, you would have a fewer integration tests. They will be more complex. They will ensure the behavior of system with different components in play. And there will be fewer of them. They will maybe harder to run. In many setups, they will be flakier. You would never know whether they fail for reasons or for like arbitrary reasons. And then that's why there will be fewer of them. And then there will be end-to-end tests, which would run in the environment close to production, where like you would have all the services, kind of sort of maybe a staging environment or maybe like a dedicated copy for the end-to-end tests. But it will be the actual like real environment, maybe with just fake data or like a slice of the production data. And it will verify at most maybe happy pass, because those tests are even harder to maintain, even like harder to set up. It's hard to run on the developer workstation. So they will be like a like an afterthought in the delivery process. So, and in the recent years, people started rethinking that, because specifically, and there are different teams and different shapes how they like transform that pyramid, which is a triangle, but people call it a pyramid, how they transform that. And the main idea there is in the modern development practices, specifically with microservices, or specifically where applications become smaller and the system behavior is sort of encoded in the interaction between different services within the fleet, unit tests do not bring that much value. If the system behavior depends on how it interacts with data stores or message brokers or external systems, then like testing a component in isolation is not that useful, because there's not so much business logic in your actual application. It takes data from somewhere, it posts data somewhere else, it does a little bit of computation, but you cannot verify that the whole system works, and you cannot have the confidence that you're going to deploy it and nothing will break if you just rely on unit tests. So people, and this is the image taken from the Spotify's engineering blog about how they test their systems, and they have like thousands of microservices in play. And they say that they have fewer implementation detail tests, and the bulk of their test suites are integration tests, where they will run their services in sort of ephemeral, specifically crafted environments, but they will work with real technologies. Like if your application needs to work with a database or with some cloud technologies or, I don't know, Kafka, they would have those services available. And then they will still have like the full end-to-end sort of integrated tests that will run in environments similar to production, but there will be less of those. And the bulk will be integration tests. And that's where they will get confidence for releasing their software very smoothly. And this is a very important point. We do need to have a solid test suite for any sort of like smooth delivery pipeline, because it's right there in the DevOps. Nobody talks about that. Very few people talk about testing in the grand scheme of DevOps, but it's right there in the left circle, like hanging there at the bottom. And it's an essential step before the release, which gives you not just the benefits of verifying that your code is correct, but also plays an essential role in all kinds of security practices. What's the point of having a fix to, I don't know, like a library accessing a random LDAP server on an arbitrary input if you can't verify that that library still works and your application still works when you release the fix? And how do you know? Like if you have like hundreds of microservices and there is a security vulnerability of one of the fundamental libraries. Okay, yeah, somebody smart enough looked at that and they implemented a hotfix, and you have a different jar that you can pull from your from the, I don't know, Maven Central or something, right? And you can update. It's very easy to update. You just say like, Maven, this is a different version, pick it up, run it. But how can you be sure that you can release that thing in production and it's like your application still works? Like you cannot manually test all that, not in the time frame that is relevant for any security hotfixes. So without a good test suite that gives you confidence for releases, well, it's just like as well as not having good security practices at all. So testing is very, very important. And more teams are pointing and putting more attention to integration tests, which is where Testcontainers comes in. So Testcontainers is a collection of libraries, and they're available in different languages, and they're very, very popular. And they're popular to the point where earlier this year, ThoughtWorks Technology Radar firmly put Testcontainers into the adopt category, which is a rare thing. Not very many technologies get there. But what's more important, they wrote a very interesting to me and very positive kind of words about it. So they think it's a default option for creating reliable environments for your tests, because it's programmable, it's lightweight, and it makes functional tests more reliable, which is exactly what you want, right? You, as a developer, you don't want to like have like external configuration to figure out how to run a database for your particular tests. You want everything to be programmable, specifically for integration tests, right? Because it's not just you need to run things once. You need to run your system in different configurations. You need to make sure like, oh, what will happen if my database is in this weird state? What will happen if my Kafka runs out of topics? Or like, if the queues become like too long, right? So, and you want to create that all programmatically. And then you want everything to be disposable because you want repeatability between your test runs. Like, it's never enough to run tests once, but you need to make sure that when you run it again and again and again, it all works out. So, and Testcontainers provides them with that, and Testcontainers provides like a lot of other projects with that. How does it do it? It relies on Docker. So it uses Docker as a runtime for running those third-party services that we need for our application to be tested with, the Kafka, the databases, the cloud technologies, and so on. And Docker is amazing. Docker provides you with an API to isolate processes and manage their lifecycle and run literally any software that sort of exists on Earth, right? Like, you need to run any technology, there's a Docker image for that. Docker is available for all operating systems, for all reasonably popular operating systems. So developers are familiar with that. There is a common sort of API into how you can run things with Docker. And it's only what is missing is that it's not flexible enough for the integration testing needs, because you really want a programmatic access to that and configuration. And that's what Testcontainers does. Testcontainers give you the container lifecycle and clean up, because it gives you the convenient API for configuring both the container and the services running in the container. And it gives you integration with your application and test frameworks, which is very, very important because you don't want to reinvent the wheel there all the time, but you can use the library that integrates nicely with everything, and then you get the best practices from the integration testing that everyone knows and loves. Right. So Testcontainers Java is a specific Java implementation of the approach. It's a very mature project. It was created 7 years ago, which is not a lot in Java years, but it's sort of very much in Docker years. So very soon after Docker was created and became popular, somebody was like, oh, maybe I should have a programmatic access to that. It sits on GitHub. All those implementations are open source. It uses the Docker Java API, which means that it runs with any compatible Docker environment. It doesn't have to be Docker desktop. It runs with anything. It doesn't use the command line, so it can do more things that you normally can do with like just running Docker yourself. And it uses that extensively, for example, for cleanup and configuring networks and making sure that containers can talk to each other, and it integrates with frameworks. How many of you use Spring? Very good, most of you. Very good, because I have the examples. We're going to get to the examples very soon, and they're Spring-based, right? Other modern frameworks like Quarkus or Micronaut integrate with Testcontainers as well, so you're not left behind. And if it's not, like it's particularly, like you can use the JUnit integration, or you can just hand roll some API calls. It's very, very straightforward, so you can introduce it to any project. It doesn't have to be a Spring application. What it does to you, besides providing the API, it does system checks. So we try really hard for tests not to fail for random reasons. Or if they have to fail for random reasons, like Docker not being found, or us not being able to expose ports from the container so you can access them. So we want to fail as early as possible, right? So that you have a clear reason. So you run system checks, and then we run the cleanup, because you can have multiple containers during every run, and you want to clean them up in all outcomes. If your test pass, there should be cleanup. If your test fail, there should be cleanup. If your test crash, there should be cleanup. If you run with the remote Docker host, Docker daemon, and your system literally crashes, there should be cleanup, because otherwise you'll have those resources hanging out there, and your next test run will connect to the old instance of Kafka, and you will be seeing like weird messages, and you will spend like 2 days debugging what's up, which is never a good thing. So cleanup is very important. And also the API there in the implementation tries to go an extra mile to kind of like nudge you into doing the right things. For example, we try very hard to avoid any port conflicts. We want your Testcontainers tests to run the same way on your workstation, on your colleague's workstation, in your CI. So if you need 2 instances of Kafka, or you want to test the MongoDB cluster with a few replica sets, you need 2 MongoDBs for that. If every Mongo will try to expose the same port and there is no randomization, they will collapse, because on the host there is only 1 port by that number. So when you do the randomization and we give you API to use that in your tests conveniently, We give you API to do the data initialization in the containers, and it all works very, very well because you can parallelize things. Because there are no conflicts, so you can run it in parallel, which is great. And the best part of that, because of that, the best part is, well, the second best part, besides this being a great approach, there is an ecosystem, huge ecosystem of modules, of technologies that somebody has already looked at and thought about how to run Kafka in a Docker container. How many of you know how to run Kafka in a Docker container? 4 people, not bad. It's not very easy. It takes at least like 200 lines of code to like correctly specify that. And somebody did that for the Testcontainers ecosystem. So all you need to do, you need to say like new Kafka container, and voila, you have a Kafka container. As an application developer, you don't need to fully understand how to configure certain technologies. You can just stand at the shoulders of the community and use those. And there is all those things that you can ask. Most popular databases and niche databases, you can run Selenium tests if you want UI tests. You can run message brokers. You can run local stack for the cloud technologies. You can run Google Cloud simulators if you use Google Cloud. You can run Azure simulator for some services like Cosmos DB if you use Azure services. And it's universally gives you confidence that those technologies will work very, very well in your integration tests. And as an application developer, you don't need to care about that. You need to concentrate on your business logic of your application, because that's what you're doing at the end. So the best thing is, the third best thing is, that this thing is available not just in Java, but in like most popular languages. There is Testcontainers Go, there's Testcontainers.NET, there's Testcontainers Node, there's Testcontainers Python, there's Testcontainers Rust. There is one person on Twitter who is working on Testcontainers PHP. No, seriously. And it's great. It's very great. He's a very sweet guy. And then he sometimes tweets about the progress that he makes. And he's like, oh, I implemented that feature from Testcontainers. And then it's very nice to see the progress. So those are mostly the community efforts. And we, at the Atomic Jar, we try to provide as much guidance and support to all the projects there. And when we're larger, we can devote more engineering power to other language implementations. But currently, we are concentrating on Java, Go, and a little bit .NET. So the rest are purely community, and we're just like trying to help people. But what is good is that you can go back to your workplace, right? And if they have teams that are doing something other than Java, the JVM languages can use the Java version naturally, right? Because there is Java JVM interop, so you can call Java classes from your Kotlin application and be all good. But you can also tell other people like, oh, look, I went to the conference and I listened to this amazing session about test containers, and I have a version for .NET, so maybe you should look at it. And then they will be very happy, and they will bring you beverages and flowers and whatnot the next week when they revamp their integration test suites. Right, so enough chit chat. Let's look at the application. We have some time here. We're going to talk about a Spring application, and this is what it's going to be. Just to give you a heads up what application is doing, even though the business logic is not, strictly speaking, very important. It's a sample application. It's a Spring application. It has the model, data model. It talks about rating conference sessions at conferences. So the data model is very simple. There is a talks identified by a string, and there are ratings identified by an integer, and they connect to things. And there are a few components in the application. There is ratings controller that is responsible for accepting the ratings from the user, and it stores data in the talks repository that uses a relational database. And there is a rating listener that listens to the ratings coming back from the system. And those two Java classes talk via Kafka, because that's how we do enterprise software engineering nowadays. And then the ratings also are stored in the Redis key value store. It's a little bit over-engineered from the point of like what the business logic requires, but it's a great example because it needs different types of technologies for the application to run. So it works great that way. So we're going to look at that, and let's see how we can do, what we can do. So here's our idea. This is our Spring Boot application. And this is, look, it is exactly, I think it's exactly what I told you. So it's a Spring application. There is ratings controller, uses Kafka via the Kafka template, and the ratings repository uses Redis template. So it talks to Redis, and the talks repository uses the JDBC template, And the exact application of like what exactly the business logic is doing is not important. It's just like you need to have a relational database to run this SQL query there. So, and I have a bunch of tests. I have a bunch of tests pre-written for us. So it's a diverse test suite, right? I have a sample test for the Spring application that asserts that the database exists and there is a sample data in it, that the health endpoint returns 200, that the sending ratings to the application and getting ratings back actually works as I expect. So the values that they send in come back on the other end. And I can repeat that a little bit. And then even that the negative passed in the application work as expected. So if we ask something that doesn't exist, a talk by the ID that doesn't exist, then we'll get for a full. So a few things here. First, we're going to use the rest assured, which is a great library for doing any sort of like functional tests where you need to access HTTP endpoints. It gives you a Fluent API. You can very easily configure it, and it's like sort of a DSL that, given the specification where we need to hit the requests, you submit, get information, and then expect things fail if something is not right. And then we're going to use Utility, which is a different library, which is a great library for working with asynchronous events, which is very often what you need in your tests, because you never know when something will happen, and you don't want to wait for with any sort of timeouts, because you want to react to the things as soon as something happens, instead of like waiting for 10 seconds and trying it again, because you want your task to be as swift as possible. So those two great libraries, you can use them even without test containers. So if you take something as a takeaway besides how great test containers is, like those two you want to remember. And it's a Spring Boot test, right? So we're going to run our Spring Boot application on a random port, and we're going to inject that into the variable here, into the field, and then we're going to say that our rest assured, we want you to go on localhost on that port. That's where our application is, so our functional test can actually hit our Spring application normally, and it all works great. So, oops. Now, I can maybe run those tests. Can I run those tests? Do you think those tests will pass? Who thinks they will pass? No. Who thinks they will fail? Very good. Very good. Why will they fail? Because there's no environment. My application needs a database to run. My application needs Kafka to run, and even Redis. And it's not just they need them to be available somewhere. It's very important. They need to be available somewhere. Those services need to be started and in a state where they actually can handle things. It's not just, I don't need to, it's not enough to have a container with a database. The database needs to be initialized and ready to accept things. And the third essential component is my application in the test needs to know where the services are. Like, it's not enough to just spin up my database in a Docker container. I also need to configure my application to talk to that database, to say like, oh, look, if you want Kafka, there is the Kafka. If you want database, there is that. So now we're gonna use test containers, and we're gonna implement this like environment creation, and you're gonna see how easy it is. And hopefully it will work on the first try. What I need to do, it's a Java, like the libraries are the Java libraries, right? So I add the dependencies in the POM XML, and you can see I have a bunch of modules from my test containers ecosystem here. Postgres, we're going to use that as a relational database. Kafka, Kubernetes cluster, MongoDB, MariaDB, Cassandra, Elasticsearch, Toxic Proxy, integration with JUnit, and so on. It's actually, there are even more of those. So if you go in the modules, you can see like there is a bunch of additional non-database technologies, and like as much as possible database technologies there. So your technological choices are most probably covered by the existing modules. And if not, you can do this very easily as well. So we're going to start here. And I will just, this class is simpler for the testing purposes. You can put the calls for that. It's just normal Java code. You can put it everywhere. So one of the things that we need to sort of know is the generic container. We're going to start with Redis, and we're going to create a new generic container, which is the abstraction in the test containers world that tells you, like, oh, this will be my instance of the container. And what I need to do, I need to give it a Docker image name, because that's what the technology will be, and I'll do Docker, I think 6 Alpine, something there. Yes, 6 Alpine works, right? So let's make it a static field. Now this Redis allows me to do all kinds of things. First, there is the lifecycle control methods. There are also configuration methods. I can configure the Docker container for everything that you can do on the command line. I can expose the ports. I can copy files into the container. I can subscribe to logs. I can override the commands if you want to run it with a custom command. I can override even the memory and CPU limits. The whole API is exposed, and it all goes through the Docker API, so it's not limited to what you can easily do on the command line. You can do complex topologies with networks if you want different containers to see each other, and so on. So for Redis is a web application, right? So we need to access that through the intranet. So we're going to expose the port, and Redis works on the 6379. So that is the port within the container, and you can see we don't even specify what's the outside the port, what's the host port that we map to, because it's not important for us. Because again, when we start working with that, we can programmatically access that information. So this is everything that you need to run to run Redis. Now we need 2 things. We need to start this container, and we need to make sure our Spring application knows where it is. For that, we're going to use the dynamic property source facility. So we're going to have the public static void method here, setup things. Setup, OK, could be setup. And it takes the dynamic property registry, which is the registry into which I can put the configuration for things. So first of all, I'm going to do the start. I'm going to start my Redis here. And I'm going to do this using the auxiliary helper method because we'll have more containers than just Redis. So I want to start them in parallel. So we just would do that. And then what I do, I can just say registry, add a string, and this is the Spring Redis host. And what I can do, I could just say Redis. Where are you running? What's your host? No, not the port. Get host. That's it. Now my Spring application with the test will run. It will run this dynamic property source method, and the configuration that you put in here will override anything that's there by default. So now so we're going to get first my port and port here. So now my Spring application will think that the Redis that it's configured to use is the Redis that we created in the container and start it right here. And with that, you can do anything. You can run any Docker image that is available for you in your private registries, in the public registries, in your public registries that you authenticate with credentials. It's just everything that you can pull on your machine or in your Docker environment will work here. And now with other technologies, it might be even easier. So we can do Kafka container, right? Kafka equals new Kafka container. And then you just need the thing. So I think it's Confluent CP Kafka. And there is a version, right? 5.4.6, something like this. We don't even need to do, it's Docker image name, right? Very good. Right? So this is how you run Kafka in the Docker, right? You specify a bunch of environment variables. You figure out what to do with Zookeeper. You understand what is the Bootstrap servers and how to create the URL for that. You configure Kafka to configure itself to work with the dynamic setup because it needs to advertise the listeners. And then you run some commands when the container started, and then you're sort of done. But as an application developer, you don't care about that. You just want to say, give me my Kafka, right? And this is what the module allows you to have. So you get Kafka, you start Kafka, and then you start Kafka and configure your application. Spring, Kafka, I think it's Bootstrap servers. And then you just say Kafka. Get Bootstrap. See, this is the best part. You don't need to mess with external configuration. Your IDE is there to help you on every step because your IDE knows how to deal with the Java API. And this is all you need to configure all those external services. On the container level, like we saw with the external ports, mapped ports, or the application level on the abstractions. So this works like a charm. What else do we need? We need a database, right? I'm going to do the Postgres very quickly, and it's very similar. So static Postgres container, Postgres, container equals new Postgres container, Postgres 14 Alpine. 14 Alpine, very good. Some IDEs even can do this, right? Content assist of the names and links to the things here, which is kind of cool. Right, so we have the Postgres. We need to start Postgres. It's very important to start things, otherwise nothing will work. And we need to configure the database here as well. There are different ways to do the configuration. This is probably the most kind of sort of straightforward that you can like to have the basic concepts. Let me just do this quickly. Spring data source URL, and this is the Postgres get JDBC URL, and then I do the same with the get username, and then get password, right? We need 3 password things. Get password, right? Data source username, data source password. Right. Is it done? Or is the parenthesis missing? Right. So are we now done? Do you think the test will pass now? If I run the test, we created all the environment. What's your thinking? Will it work? Who thinks it will work? Very rarely works in the first try, because I always make typos somewhere. Wait, what? Oh, it's Confluent Inc. See? Told you. You can, like, if you use non-common images, you can still do that. It's very easy. But, like, you need to make sure that when you use modules, you need to make sure that the images are compatible. So we can run the same Kafka container with different versions of Kafka. But, like, if you're running something that is non-default image name, right, then you need to call an API to tell that, yeah, you know that this image is compatible. If you use, like, for example, internal images that you use at your company. So what happens now is my Testcontainers library started to initialize. It found the Docker environment and connected to Docker, and then it pulls the images if the images are not in the cache, and then it runs the images, and you can see that they started somewhere, and then it starts running the tests. And then you can see the tests pass. Oh my God, this is amazing. The tests pass, and this is great. Isn't it great? I like it when tests pass. It's those brief moments where a developer is sort of happy. And then you need to take the next issue, and then you're back struggling with the right tests. But those moments are great. You have a question?
Yeah. So the test needs access to the internet to get to Docker Hub?
You can use the internal registries, so it doesn't have to pull images from Docker Hub. But like it can pull images from your private registries inside your VPN networks, or if you pull images from like public internet registries, it can do it from there. But in general, if you even have your images locally available, so you had internet at some moment, you pull the images, and then you run it now, it will use the local cache without necessary internet access. So all it needs to do, it needs to have access to Docker environment, and then the images need to be present there. But it doesn't implement it like a custom pooling images technology that just relies on Docker to do that. So that will work. Right. So, and now there's configuration options that are available to us, right? We have a few moments more. Yes, absolutely. So now you saw me here doing this trick where my database is initialized by Spring, right? This is very convenient in development. Like you just say like, oh, there's my model, just create a database for me. But this is not great for tests because you don't do that in production. So there are a number of configuration options that you can do for that. You can use any database migration technology that you use, for example, Flyway, and it would work the same way, right? You would tell Flyway, here's my database, and when it's initialized, it finds the migrations and applies the migrations. Or you can do the thing, and I want to show you how easy it's to do the configuration of the services within the containers. I can take my schema, which I have here, a schema. I have a schema SQL here that creates the custom data, and I can say that get my schema SQL, and put it in some path in the container. So most images have some configuration things that you can do. So init d. Where's the location of that? Initialization scripts. For Postgres and most databases, if you put the configuration under the Docker entry point initdb d, it will be a part of the container startup and the schema will appear. So I can do that very easily. I can just put it here. And now my Spring application will not initialize the thing, but I can still run my tests. And then the file from my host will be copied into the container, and the container will start. And then the container will be like, oh, I have my schema here, so let me initialize that. So this is very convenient. And in a similar way, you can do anything. Like if you have custom technologies, I don't know, like Kong, like service mesh or something, and you need to put a YAML somewhere in a Docker container for the configuration to take place, there's an API to do that very naturally. You can just have the files. And you can see the thing runs. You can also see that if I mess this up, right? If I mess this up, just to show you, the test should fail with the schema not being available. Never trust a test that you haven't seen failing, because maybe it tests different things. So it will fail now. And now you will see we start the containers, and the container starts very, very fast. The container starts very, very fast, so it's not a problem to run this in CI, but sometimes when you want to run it constantly in development, it's a little bit annoying that you need to wait like even a few seconds for the containers to start. So you have the full control over how exactly you want to run the containers. You can run them manually like this, like I show in this example. You can annotate things with the JUnit 5 annotations. For example, I can put test containers on top and say container on the field that represents the container. And then it will be tied, like we have a JUnit extension, and it will tie the lifecycle of the containers to the lifecycle of your tests. So if it's an instance field, it will be started for every test method, like sort of before each, after each. Lifecycle will be like that. If it's a static field, it will be before all and after all, so once per class. And if you want anything more complex, like start containers once, you just need to put them in a class, initialize that class, start the containers. You can do this, or the framework can do that for you, or your the project can do that once, and then you never need to know, you need to think about what's the correct life cycle for that. So here we use it manually. You can also use, especially for local development, you can go in it further. You can use a special reuse mode, which is very interesting because it will opt out of the cleanup, and it will keep the containers running, and then it will be pretty good. True. Because then we don't need to start the things again and again and again. And it requires both the API usage like here, and then, wait, let me run all the tests. It requires the API usage like that, and it also requires environment consent. Because you never want like your random API call to leave containers behind, because you never know where you run. You might be running in a shared environment in your CI server, and then if the environment doesn't consent, it shouldn't have the reusable containers. So the containers should be cleaned up. But it's pretty simple. So I can do, what can I do? I can do test containers properties, which is the configuration, and I can do the reuse. And you set up the properties in the file that is in the environment, and then your containers are started. So this is first time when we added the reuse. I think now if I do docker ps, yeah, you can see the containers here are still running. So those are the same container. And if I run the test again, then this startup sequence is much faster because, well, there is no starting, right? So we can see reusing the existing container because it takes the configuration that is in your Java code and it hashes it, and it adds that hash as a label to the container. So if the configuration didn't change, it will reuse the container. And if the configuration did change, then it will spin up a new container, which is what you want. You need to clean up those containers manually though. So, because if you want to stop using the reuse mode, the containers are still running. That's the downside of the reuse mode. Yes, we have a question.
So I know it's not really what you're going for with like keeping the tests contained in one project, but if you did want to use that Kafka to have two projects talk to each other, can you use reuse in two projects, and will it use the same container, or will it spin up like a new stack for the other?
Yeah, it will. By default, it will spin up the new stack. So the thing is, you cannot use the container. You cannot create the abstraction from the running container. Maybe yet. There was an issue on GitHub. You can upvote that. It probably requires like a fairly big refactoring of the how we configure containers. I know that some frameworks can do that. For example, Quarkus offers dev services, which is an excellent use of test containers, where when you start your application, you don't even run tests. You start your application, and it sees that it needs to access a technology like Kafka, and there is no configuration where the Kafka is. It will I need Kafka, but you don't provide me with Kafka, so let me spin one for myself. And then it will spin up the Kafka thing. And then if you run two Quarkus microservices that access Kafka, then it will be like, you want probably to share a single Kafka instance between those two. And it's really, really great how it works, because then you don't need to worry about the external environment at all, even when you run the things, which is great. So maybe this is something that we can somehow implement in test containers as well, but it also sort of requires integration with the actual application framework, because it needs to know. Or maybe the big rehaul of the configuration API would make it work. Right, so we did this, we did that. Dynamic ports, right? Dynamic ports, this is something that I want to show you. This is something that I wanted to show you. Now our database is fully dynamic here. So we don't know what's the JDBC URL. We don't know what's the container ports there are, because they are, Docker PS. I can always look at that from here. So where's my Postgres? Here. So on host is 54188. But it's a little bit inconvenient. Sometimes you want to have like a fixed port for your debugging purposes, right? So, and you don't want to expose fixed ports in the configuration here. But what you can do, you can very easily, and I'm going to take this snippet because there are not enough time. But I can create a proxy, which is like a Java proxy library. You can do any sort of proxy, right? But here's it. It's a TCP proxy. It comes from a library called Java NeoP proxy. And what it does, you can take it and you can put the fixed port that you will have. And because of the library, because it's a proxy, right? It will not complain if you start it again and again and again. So I can create the proxy. I can start the proxy. Now I just need to call this method. Oh, it's before all. I don't know if, let's do this. We start the database and then we create the proxy. Right, and I can run my test. I need, context loads. Here's an amazing trick. Don't do this at home. Some people say that this is achievable with the debugger, but it's easy for me like this. So now the test will run, right, and the test will stop on the scanner, right? So, and what I can do then, I can exit presentation mode, and I can run my database, and I can say that, okay, this is my local host, and this is my, where's the port? Okay, 5900 test connection. Yes, my database is there. Okay, so we can see the proxy works. Let's refresh. Okay, we see it here, right? We have a table called talks, and this is exactly the data that we wanted there, which is great, right? So we created the proxy, and our database, now our IDE goes into the proxy, and the proxy proxies it to the dynamically created Postgres, and it works very well. And now in my test, if I don't need this proxy, right, I can nop it with like a condition that only start this in development mode or something, or locally. And my actual test will still be dynamic, so you can run them in parallel. There is no problems with that. And the proxy will just not fail hard if there is another proxy running, because it's just the proxy doesn't, like it assumes that it's already running there, which is great. So you can do that, and you can do even more. You can do some chaos theory, what's it called? Chaos engineering things, right? Which is absolutely great. So let's not do that. I will leave that as an exercise for the readers, for the watchers, for you as an exercise. There's a technology called ToxiProxy, which works with Docker networks. So you can wrap your containers in networks and start ToxiProxy and proxy via the ToxiProxy into your technology, like say Redis. And it's fairly simple. You can read the docs. I'll show you actually. I will not create that, but I can show it to you. ToxiProxy, right? And then you create the container for the ToxiProxy, and you say that, oh, now I want to get my Redis via the proxy. And then you can introduce all kinds of cool effects, like latency or cut the network. And in your test, you can see like what will happen with your application when Redis is down. Like it might be a valid use case, or if Redis is super slow, right? Are there timeouts in place, and so on. So it's an interesting way to do this. There's also another module that also does sort of a chaos engineering techniques from Streambit. Right, so this is, but in a nutshell, this is it, right? Now I can commit those things, and everything will work as expected, right? If I do Maven test, I think it will run everything just as I need. Yes, it runs, see? So now it starts things and it runs things, and now I can run those tests, and they work with real technologies. So my SQL could be like my database specific, and I know that the driver for Kafka works, and everything like that. And I know that my highly functional tests work because they just touch the API. I can safely do internal refactorings because my test suite doesn't depend on the implementation detail. They're all good benefits. I know that my application actually works as it sort of intends to, like it was intended to do, so I can safely release that in production. I can also commit all this. The configuration is in the code, so it never gets old, right? It never gets stale because it's not like external files. There are no YAML, which is a win in my book, because I know how to work with Java API. My colleagues can run those same tests. My CI can run the same tests. Oh, shoot, I know what happens. Stop it. Before you commit, remove hacks. All right, my colleagues can run the same tests. I can run them again in half a year when I come back to the project. And it all runs universally. All that is needed is the valid Docker environment and our test pass, and we are happily going to the next issue. Right, so, and you can do more. You can do custom waiting and startup strategies to wait for your technology in the Docker container to be ready. You can do complex networks or complex setups. Like if you want clusters of things, you can have an abstraction that spins up multiple containers and just acts as a like sort of aggregated object. If you need, I don't know, Kafka and the schema registry, right? You can have an abstraction that starts both and then gives you information about individual ones. You can create images on the fly for Docker files. You can access logs, you can file the commands, you can execute commands in the container while the container is running. You can copy files back and forth. It's a very, very flexible approach. And it's all available, the best part, it's all available for you from the IDE, which means that even if you don't know what you can do, right, you can just sit there mindlessly, like press dot and then like go down, down, down and see what you can do, which is excellent because it reduces your cognitive load. Right? As I said, there is also technologies that integrate with test containers for local development. Quarkus has dev services. Micronaut has test resources. Spring has an issue that you can upvote, for implementing maybe something similar for that. There are prototypes, but it's not in the main lines anywhere yet. Right, and then a very common question is, what if you don't have Docker? You don't have to have Docker desktop. Any compatible environment will work. Last year we ran the tests. We run actually Testcontainers Java test suite itself on different environments. Docker desktop obviously worked because it's the default. Docker machine, which is an older way to run Docker on Mac and Windows, which is sort of deprecated currently in favor of Docker desktop, but it still works. Minikube, which is the Kubernetes implementation for like development environments, and it exposes Docker API. It worked. You just need to, well, configure it a little bit. We tried Podman on Windows and Mac OS. It didn't work out of the box. We created issues and are working with the team, with the Podman team to figure it out. And internally, at Atomic Jar, we're building the product, which is Testcontainers Cloud, which is sort of the serverless backend that you can use to, like, on demand, create environments to run your containers from the tests, which works really great. For example, this is my M1 Mac. I don't know if it runs all the Docker images that I need because ARM. And then, well, I don't have Docker. I have Testcontainers Cloud, and I run all the tests, and you didn't see any difference. You didn't even notice. The containers were running in the cloud, didn't take any load from my machine here, and it's all around great. It's currently in the private beta, which means that there is no direct way to get access to that, which is why I'm very happy to tell you that there is a URL that will be live for like a few hours that you can go, and you can get into a Testcontainers trial that will be available for like a week or maybe a few weeks. And then if you use it and if you like it, you can just talk to us more and then convert it into the proper private beta. But you can try it like very easily now, which is very good, I think. Yes, so that's bit.ly, Jconf dev, TCC. You need to authenticate with GitHub, and then you will be in the system. So if you have your laptop somewhere like nearby in the next few hours, just try to do that if you're interested. Right, and if you want to learn more, the website is testcontainers.org. This sample application that you saw here is actually the part of a workshop where you can introduce the test and introduce the containers, and it has words about why we did particular things in a particular way. It's available there on GitHub. It's not here, but it's there under the Testcontainers org. And if you want to talk to us, there is an open source Testcontainers Slack. You can join the workspace, and there is both the maintainers team and the people from the community who is hanging there. And then if you have any questions, that is a good way to sort of ask them because, well, that's the most interactive. We do sort of monitor Stack Overflow and try to answer questions there. And on Twitter, if somebody complains very loudly. But the official way is, is to go through Slack because that's the easiest. There are more people, more eyeballs who can help you. So yeah, I think that was it. Thank you very much for coming. Sorry? The project? Yes. It's goes by the Testcontainers / workshop, and it leads you through the tests. And then, yeah. Yes. I also reuse it for some other things. So if you want, you can just ping me, and I give you the link to the branch where it's like the final state.